In this video, we will explore two big pictures or maps. In the first map, we will look at the different tasks that can be performed with machine learning. In the second map, we will see various machine learning algorithms categorized under supervised and unsupervised learning, deep learning, and reinforcement learning. From a task-oriented perspective, let's divide learning into deep and classic and understand that mastering classic learning is a prerequisite for diving into deep learning. Classic learning can be supervised, which involves labels or a target variable, that is, the column we want to predict. This could be predicting tomorrow's progress, the direction of a price movement, the reliability of a shooting star, or any of the hundreds of possibilities we could list. Supervised learning is divided in two. First, regression. That means predicting numbers. For example, predicting the probability of a trend continuing like A, 82%, and second type of supervised learning. Classification. That is predicting between classes. For example, predicting that a current support break is reliable or not, if an equity will move up or down, or if we should buy or hold. Unsupervised learning does not include a target variable. Instead, it extracts information from the data. Two common examples are, first, clustering, grouping stocks in an index based on technical indicator conditions, and second, dimensionality reduction, which consists in managing less data without losing information. Anomaly detection is also crucial. It can be performed with labeled examples, that is, supervised learning, or by extracting information from the data without labeled examples, that is, unsupervised learning. When we move on to deep learning, and I stress the importance of mastering classic learning first to avoid mistakes, we see various exciting possibilities like image recognition, chatbots, reinforcement learning, and the exceptionally fascinating generative artificial intelligence. In technical analysis, generative artificial intelligence stands out by helping to generate analytical code, create images of potential patterns, or generate synthetic data, critical for incorporating machine learning into technical analysis due to the limited availability of significant data. Regarding the second map, we approach it through algorithms and models. There are three types of models in machine learning. The first is based on statistical inference, which we discussed at the beginning of the course. It is divided into supervised and unsupervised algorithms. Supervised algorithms can classify like a decision tree or support vector machine, or perform regressions like a regression tree or linear regression. Additionally, ensemble methods combine multiple models to improve performance and robustness. In the unsupervised area, we've already seen clustering possibilities like k-means or db-scan, dimensionality reduction like the PCA, anomaly detection like an isolation, forest, and pattern search. Just like in supervised learning, ensemble methods can also be applied here. On the other hand, moving into more complex algorithms, we can mention those combining statistical inference and deep learning, like generative artificial intelligence and neural networks. And in the third model type, those adding control theory and dynamic optimization to statistical inference, namely reinforcement learning.